Good morning, and good afternoon. Today my group are going to discuss about three types of spool engine, which is single spool engine, twin spool engine, and triple spool engine. Alright, my name is Muhammad Faiz bin Kamal Arifin. I'm going to lead about single spool engine. So, for the introduction about single spool engine, the term single spool refers to the fact that there is only one shaft. This shaft connects one turbine section to one compressor section. Other compressor consists of rotating and stationary components. A shaft drives a central drum retained by bearing which has a number of annular airfoil rows attached usually in pair. One rotating and one stationary attached to a stationary tubular casing. They produce thrust by increasing the velocity of the air flowing through the engine and operates on Newton's third law of motion. For every motion, there is an equal and opposite reaction. So, how they work? How the single spool engine works? During operation, the rotor is turned at high speed by the turbine so that air continuously induced into the compressor, which is then accelerated by the rotating blade and swept rearward onto the adjacent row of stator bands. The pressure rise results from the energy imparted to the air in the rotor which increase the air velocity. The air in the decelerated diffuse in the following stator passage and the kinetic energy translate into the pressure. Okay, now we already know about how the single spool works. So, what is the advantage and disadvantage about the single spool engine? So, the advantage is the single spool engine is so simply designed and lower maintenance. So, it's not quite the efficiency for the current disuse. So, the disadvantage is require large starting device, limited speed range, and lower efficiency, like I said before, and it's not commonly used in the worldwide worldwide engine. Okay, now we will proceed to the Shazwan Shahmi for the double spool engine.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Shazwan Shahmi. So I will continue about dual or twin spool engine. What is twin spool engine? The engine designer devised a way by splitting the compressor into two or three sections. Each connection connects to a portion of the turbine section by coaxial shaft. Thus, dual spool or twin spool compressor engine is introduced. How it works? In a dual spool engine, the compressor and high pressure turbine are both split into two segments. Each compressor segment is driven by its corresponding turbine using two separate drive shafts with one inside the other. The front section of the dual spool compressor is called as low pressure, low speed or N1 compressor. The second section of the dual spool compressor is called high pressure, um, high speed or N2 compressor. The shaft which connects the low pressure compressor and turbine typically rotates inside the shaft which is connected to the high pressure compressor and turbine. For some turbofan engines, the forward fan is attached to the low pressure and both turn at the same speed. Since the spool are not physically attached to another one, so it's the best operating speed. However, at any given power level setting, the speed of the high pressure compressor is relatively constant depends on the setting of the fuel control governor. At a constant level of energy at the turbine, the speed of low pressure compressor increase or decrease with the changes of inlet airflow caused by the atmosphere pressure, fluctuations or flight maneuvering. For example, 1. The low pressure compressor will increase in speed when the aircraft gains altitude because the atmosphere is less dense and more, ras- more rotational speed is necessary to force the required amount of air through the engine. Number 2. When the aircraft descends, the air will become more denser and compressible, so the low pressure compressor will begin to slow down. The low pressure compressor supplies the high pressure compressor with a constant air pressure and mass airflow for each power setting. Example of twin spool engines. The advantage of having twin spool, because there are two rotating assemblies that can vary in speed, the engine more capable and better at handling sand sand apa ni babi? Sand digestion. Nanti kau delete okay. The advantage of having twin spool, because there are two rotating assemblies that can vary in speed, the engine more capable and better at handling sand digestion than a single spool engine, which would incur much greater degradation to engine components. As a result, a dual spool design fosters greater time on wing and less downtime for maintenance. Alright, thank you. So I will give to Muhammad Nakib then.
I will continue with next question is triple spool engine. Okay, what is triple spool engine? First, a triple spool engine is one that has three sets of compressor before the compositor and three sets of turbine behind it. Second, a spool is made up of a compressor and a corresponding turbine used to extract the power from the exhaust gas to turn the compressor. Third, each spool is given a name. First N1, N2, and N3. N1 is the large fan section in front of the engine. N2 is the low pressure compressor section. And N3 is the high pressure compressor section. Some engines incorporate N2 and N3 into one rotating mass and call it N2. Hence the double spool engine. All modern engines have two sets of compressor bracket HP and LP. And a fan section provide a vast majority of the tasks. In a two spool motor the HP section and the LP section are joined. The number of spool in an engine tell how many set of compressor blades and corresponding sets of turbine blade the engine has. A single spool engine has one set of each, a double spool engine has two sets of each, and a triple spool engine has three sets of each. Second question is what are the work? First, the incoming air is captured by the engine inlet. Some of the incoming air pass through the fan and continues on into the core compressor and then the burn where it is mixed with fuel and combustion occurs. The hot exhaust pass through the core and fan turbines and then out the nozzle and in a basic turbojet. The rest of the incoming air pass through the fan and bypass or goes around the engine just like the air through a propeller. The air that goes through the fan has a velocity that is slight increase from free stream. So a turbofan gets some of its thrust from the core and some of its thrust from the fan. The ratio of the air that goes around the engine to the air that goes through the core is called the bypass ratio. Triple spool engine advantage and disadvantage. First, more set of blades result in a greater engine weight, but the corresponding increase in thrust possible more than offsets the weight increase. Second, major advantage of triple spool engine is its ability to minimize engine circuits. Third, the drawback of a triple spool engine are increased weight, complex and cost to purchase and overhaul, but they are the most efficient engine flying. Last question, category triple spool engine. Category triple spool engine. You can see D underscore 18T, 180, NK dash 25, and RB1 or RB211. Next, I will pass to Wan Ahmad Syami bin Wan Zainal Abidin. Thank you.
Assalamualaikum and very good morning. I am Muhammad Syami. Today I want to present to you about twin spool application in aircraft. Uh, there are two types of twin spool application, and type that is basic to spool. In aircraft, there is a Pratt and Whitney Canada that is well known as PW600 series. It is designed with scalability in mind. The engines can produce between 900 lbf and 3000 lbf of take-off thrust and boosted to spool. The General Electric CF6 produced by GE Aviation. And the CF6 powers a wide variety of civilian airliners. The basic engine core also powers the LM2500, LM5000 and LM6000 Marine and power generation turboshaft. It is gradually being replaced by newer GE&X family. Since then, the CF6 has powered version of the Airbus A300, A310 and A330, Boeing 767 and McDonnell Douglas MD-11. Next is GE90. The General Electric GE90 is a family of high bypass turbofan aircraft engines built by GE Aviation for the Boeing 777. With thrust rating from 81,000 to 115,000 lbf, it entered service with British Airways in November 1995. It is the most powerful and was the largest jet engine until its 6 in 15 cm wider fan successor. It is powered by the Boeing 777X first flight in January 2020. Next is the JT9D. The Pratt and Whitney JT9D engine was the first high bypass ratio jet engine to power a wide-body airliner. It was Pratt and Whitney's first high bypass ratio turbofan. It subsequently powered the Boeing 767, Airbus A300 and A310 and Douglas DC-10. Lastly, PW400. The Pratt and Whitney PW4000 is a family of high bypass turbofan Aircraft engines produced by Pratt and Whitney as a JT9D successor. It made its first run in April 1984, was FAA certified in July 1986, with thrust ranging from 50,000 to 99,040 lbf. It is used on many wide-body airliners. It powers the Airbus A300 to 600 and A310 to 300, Boeing 77, 747 to 400 and 767 200/300, and McDonnell Douglas MD-11 wide bodies. That is all for me. Let's move on to Hazim Zafri.
Assalamualaikum and good afternoon. My name is Muhammad Aziz Zafri. Today I want to talk about aircraft that use triple spool engine. Triple spool engine architecture of RB211 is continued by the Rolls-Royce Trent Company. For some example, they make Trent 700, Trent 800, Trent 500, Trent 900, Trent 1000, Trent SWB, and Trent 1000. Trent 700 is used on Airbus A330 that weigh 6,060 kg and produce 360 knot of thrust. The Trent 800 is used on Boeing 777 that weigh 6,000 at 78 kg and produce 415 knot of thrust. Trent 500 is used on Airbus A340 that weigh 4,990 kg and produce 250 knot of thrust. Trent 900 is used on Airbus A380 that weigh 6,246 kg and produce 774 knot of thrust. Trent 1000 is used on Boeing 777 that weigh 6,120 kg and produce 331 knot of thrust. Trent SWB is used on Airbus A350 SWB that weigh 7,277 kg and produce 413 knot of thrust. Trent 7000 is used on Airbus A330 neo that weigh 6,445 kg and produce 360 knot of thrust. This is some example for Trent 700 and Airbus 330. This is the Trent 800 and Boeing 777. This is the example for Trent 500 engine and Airbus 340. This is the Trent 900 engine and Airbus 380. This is the Trent 1000 and Boeing 777. This is the Trent XWB engine and Airbus A350 XWB. This is the Trent 7000 and Airbus A300 330 neo. That's all. Thank you.
Okay. Thank you for the information, Muhammad Aziz Zafri. And that's all for today. I hope our presentation will be good enough. And that's all for today. Thank you and goodbye.